Chapter 4.1, Day 2, Graphing Polynomial Functions. To graph a polynomial function, first plot points to determine the shape of the graph's middle portion, then connect the points with a smooth, continuous curve and use what you know about and behavior to sketch the graph. Now we are going to discuss example number 4, graphing polynomial functions. We are going to use the table method to find the coordinates, and we are going to plot those coordinates to find the graph. So first thing we are going to do is we're going to use these x values and plug it into the fx function to find the y value. So I'm using x equals -2 and plug it in for x value. Using PEMDAS, I'm going to use -2 cube means -8 inside the function. I did not use the negative outside yet. And -2 squared is 4, -6 minus 3. You have two negatives that cancel each other, and you're going to have here is 8 plus 4, that's 12. 6 minus 3 is 9. So 12 minus 3, your answer is going to be for y value is 3. And your coordinate point is -2, 3. That's what we're going to plot. Next, I'm using x value as -1, so -1 cube plus -1 square plus 3 times -1 minus 3. So the first term would be -1 plus 1 minus 3 minus 3. So that's going to be negative cancel, 2 minus 6, and that's going to be -4. And the coordinate point is -1, -4. Put x equals 0 and all the x terms. So wherever you see the x terms are going to be 0. And your answer should be -3. 0, 3, -3 is your coordinate point. And then you're going to use x as 1. So 1 cube, -1 cube plus 1 square plus 3 times 1 minus 3. -1 plus 1 plus 3 minus 3. When you're going to solve this, the negative and positive cancel. Answer is 0. Coordinate is going to be 1, 0. Next, you're going to use x as 2. So -2 cube plus 2 square plus 3 times 2 minus 3. And that's going to be -1 and the coordinate point 2, -1. Now I'm going to plot these points. So the points are -2, 3. This is this point, -1, -4, 0, -3, 1, 0, and 2, -1. So when you connect the points, make sure you use the curve graph. So connect the points with a smooth line, and you're going to get this graph. So avoid making the corners for the turning graph. So avoid writing the corners or making the corners for the graph. So try to make a smooth as much as you can. Now we are going to answer some of the questions on the bottom, so which is degree of the polynomial. So you can see that the degree of the polynomial is 3. So the degree is odd and it is 3 in value. Leading coefficient is the number that is next to the highest degree term. So that's going to be -1, and degree or leading coefficient is negative. Now we are going to answer some of the questions here. Identify where the function is increasing. Increasing function is that function which is a rising function, rise from left to right. And if you look at this graph, you can see the function is rising from this point to this point. So from this point to this point, the function is increasing. We can name the point here. So the point here is -1, 4. -1, -4. And the point here is going to be 1, 0. So within the graph, you will see some of the curves. So in this one, the curve that is going or rising is this curve. Starting from the x value -1 to +1, the graph is rising. So we only going to answer the x values. So from -1 to +1, the graph is rising. Don't worry about the y value, only x value to x value. Okay. Now, if I want to write the coordinate for this arrow, is x in this one is -infinity because it's the left side, and y is +infinity. If I want to write the coordinate for this arrow, that is going to be +infinity for x and -infinity for y. So the decreasing is the curve that you can see are falling from left to right. So I see two curves here. I see this one is falling from left to right, and I see this one falling from left to right. This curve is falling from left to right, and from x value -infinity to x value -1. So my first curve is -infinity to -1. My second curve that is falling from left to right from -1 to +infinity. So from 1 to +infinity. The graph is falling from -infinity to -1. That is the first interval. The graph is also falling from 1 to infinity. That is the second curve. Now we are going to write down where the function or the y is greater than 0. So I see this right here. This line is our border line. Anything above this line, the y is greater than 0. Anything below this line, the y is less than 0. If we are talking about y is greater than 0, from this to all the way up, y is greater than 0. So from -2, so let's say if it's cutting at -2, and it is cutting at -2. So let's do this point is -2. I should have this one cutting at -2. So this is -2, 0. The graph is positive on this section. So what is this section? This section is -infinity to -2. The graph is positive, or y is greater than. So our coordinate should be -infinity to -2, Or in other words, we can see that y is greater than 0 if x is less than -2. If x is less than -2, the graph is started going up and up and up. So that's why y is greater than. From this point to this point, graph is less than 0. The y is less than 0 from -2 to 1. So from -2 to 1 is less than 0. And again from 1 to infinity, 1 to infinity. From here to all the way is going down and down and down on the right side. So it's going to be 1 through infinity is also y is less than 0. I'm going to discuss another example for more clarification. And this time the example is a quartic degree 4. And this is going to be either a U or a W graph. The process is same. We are going to make the table, find the y values, find the coordinate, and plot these coordinate to make a graph. So we are going to plug it -2 for x and in the function. So -2 to the power 4, -2 to the power 3, 4 times -2 to the power 2 plus 4. -2 to the power 4, since it's an even degree, it will make it positive 16. This negative times negative would be positive 8. Remember, if you have a negative exponent, it will change the negative into negative. So it will remains negative into negative actually. So that's going to be 16 plus 8. -4 times 4 would be -16 plus 4. 16 negative and positive cancel. 8 plus 4 is 12. So your point is 2 comma 12. When you plug it in -1, -1 to the power 4, 1, -1 to the power 3 is -1, -1 times -1 is positive 1, -4 to the power 1 should be -4, and that 4, positive and -4 cancel, so answer is 2. When you have 0 for x, all the time where the x is there, going to be 0. So leftover is 4. So the point is 0 comma 4. When you plug it in 1, that's going to be 1 square, 1 to the cube, 1 square. That's 1, that's -1, -4, and 4. Cancel the negative and positive, answer is 0. For 2, 2 to the power 4, 2 to the power 3, and -4, 2 to the power 2. So that's going to be 16, -8, minus 16 plus 4. You cancel the -16 and positive 16. -8 plus 4 is -4. This is going to be an even degree because it's x to the power 4. And leading coefficient is going to be positive. So next I plotted the points. -2 comma 12 is this point. -1 comma 2, 0 comma 4, 1 comma 0, and 2 comma -4. So I made this graph starting from this point and made a curve and is passing through this point. You can see that this is a U-shaped graph, although it's cutting the x-axis at only 2 points. It means that two numbers, two x values are going to be real numbers, but the other two x values can be imaginary number. Now we are going to find out the increasing and decreasing. So there are two curves that are increasing. So from here to here, this is increasing graph, and from here to here is increasing. From this arrow to down this point is going to be decreasing, and from this point to this point is also decreasing. So this part right here is increasing, and this part right here is increasing as well. we are going to write this time in a inequality form that if x is greater than -1, so if x is greater than -1 and less than 0, the graph is increasing. And if x is greater than 2 and less than infinity, the graph is increasing. So for the increasing graph, if we want to write it in an inequality form, we are going to write it as if x is greater than -x and less than 0, the graph is increasing. And if x is greater than 2, so it's greater than 2 all the way to infinity, then graph is increasing as well. For decreasing, there are two curves starting from here to here. This is decreasing, and starting from here to here is also decreasing. So if x is less than 1, so if x is going this way, the graph is decreasing because the graph is going down. If x is less than -1, graph is decreasing. And if x is between 0 and 2, the graph is decreasing as well. So from here to here, the graph is decreasing from 0 to 2. So if the graph is greater than 0, or if the x is greater than 0 and less than 2, the graph is decreasing. And if it is less than -1, it's also decreasing. For y greater than 0, y greater than 0 means the graph when which values of x give you graph that is above the x-axis. So we're talking about this graph right here and this graph. So what values of x will give you graph that is greater than 0? So right, starting from here, it's decreasing from this to this. But from here, or less than 1, the graph is all greater than 0 or above the x-axis. So we are going to write down the x value where the graph is above the x-axis. The x value that is x less than 1. So you can see when the x starting from here, from 1, the graph is all greater than 0 or above the x-axis. From 1 to 4, because this is 1.0, 1, 0, and this is 4, 0. From 1 to 4, the graph is less than 0. So from 1 to 4, when the x is greater than 1 and less than 4, the graph is below the x-axis. And again, starting from 4, the graph goes again above the x-axis or greater than 0. So it means that from this point, x is greater than 4, the graph again is above the x-axis or greater than 0.